Alright, this is part 2 of our Unit 10 review videos. In part 1 we did question 1 through 5, so we're picking up with question 6 here on your review. And just to recap, we were working with these tables and analyzing where we had vertical asymptotes, horizontal asymptotes, and or holes. And the first table gave us a vertical asymptote, second table gave us a hole in the graph, so guess what? We're probably going to have a horizontal here. So let's analyze what the tables are telling us. In this left-hand table, our x values are approaching infinity. We're getting closer and closer to infinity there. And our f of x values are approaching a number, which is 104. And then this table over here, our x values are approaching negative infinity this time. And our f of x values are approaching the same as the other table, 104. So that tells us if x is going to either positive or negative infinity, that's telling us, and y is approaching a specific number, that's telling us we have a horizontal asymptote. So if we made a sketch of this, we would have a horizontal asymptote, let's list it, at y equals 104. So we'll put in coordinate plane here. This is not necessarily a very good scale, but we'll make it work. So here's our horizontal asymptote at a y value of 104. So at the far right side of the graph, this part, as x goes to infinity, y is approaching 104, in this case, from below. So let's get another color here, we'll use green. So it's coming from the bottom and approaching that horizontal asymptote of 104 as x goes to infinity. That's what happens at a horizontal asymptote. And then on the left side of the graph, this table right here, as x goes to negative infinity, we're approaching 104 from above. The y values approach 104 from above, so it's coming from above like that. And anytime you have a horizontal asymptote, as x goes to negative infinity, so far left side of the graph, and as x approaches positive infinity, far right side of the graph, your graph must approach, snug up to, get close to, infinitely approach the horizontal asymptote. So we had all of the different cases here in the tables. So in problem 4, our y values were going to positive and negative infinity, so that was a vertical asymptote. In problem 5, the x and y's were approaching and getting infinitely closer to a specific value, and that was a hole in the graph. And then in 6, our x values were approaching positive and negative infinity, so that was giving us the horizontal asymptote. So next we'll move to problem 7. Okay, problem 7, they want us to put this in proper rational form, give the domain and identify all asymptotes, horizontal, vertical, and slant. So it starts out this way, 5x plus 1 over x minus 3. Okay, I don't care if you put it in proper rational form unless you identify that there's a slant, and then you have to. In this case, it is not in proper rational form because they are the same degree, the numerator and denominator degrees match, but I'm not going to make you do that on the test, so we'll start this way. So we start with the horizontal, blah, blah, needs TC. The exponents are the same in this case. They're both an exponent of 1, top and bottom, so we divide their coefficients. So that gives us a horizontal asymptote at y equals 5 divided by 1, 5 divided by an implied 1, 5. 5 divided by 1 is 5. So horizontal asymptote at y equals 5. That means, let's list everything. Slant, we're going to have no slant. Vertical asymptote we will have. They also want, what else did they want? They wanted horizontals, slants, verticals, and the domain. So let's list the domain. So slants, none. Vertical asymptotes come from factors in the denominator that do not cancel. So that's a vertical asymptote at x equals 3. No holes. We need to list that. Holes, none. And then domain is x cannot equal 3. You cannot have any x values where you have a vertical asymptote or hole. So domain, it gets excluded from any of the factors in the denominator. You can't have the denominator equal to 0. So that answers everything on problem 7. Let's go to 8. Problem 8 here. So they want us to identify domain, locations of discontinuities, vertical asymptotes, holes, horizontal asymptotes. If we have a hole in the graph, we need the x and y coordinates, so we need the ordered pair, and then sketch it. It says use a graphing calculator, but you will not have a graphing calculator on the test. And since we've been through the entire unit, you have all the information you need to be able to completely graph it without a calculator. So it starts this way, x minus 2 over x squared plus x minus 6. So it is bigger on bottom. The exponent is 2 on the bottom, 1 on the top, bigger on bottom. So that's a horizontal asymptote of y equals 0. Since we have a horizontal, we don't have the slant, so none there. We need to fully factor next, so x minus 2 over, that would factor to x plus 3, x minus 2. All right, so factors that cancel give us wholes. So we have a whole at 2 comma whatever the y value is, we'll find that in a moment. And then factors in the denominator that do not cancel give you vertical asymptotes. So we have a vertical asymptote at x equals negative 3. So that means the domain is x cannot equal negative 3 and x cannot equal positive 2, because that's where we have vertical asymptotes or wholes. So the domain is restricted by what makes the denominator 0. So discontinuities, we're going to use these same numbers again. So those occur at x equals negative 3 and at x equals positive 2. All right, so now we just need to find the ordered pair, the y-coordinate for the whole, and then we will sketch it. So we're left with, after we've taken out the x minus 2 factor, we're left with 1 over x plus 3. And we need to evaluate that when x is equal to 2, because that's where the whole is. So when x is 2, what is y? That's what we're finding. So 1 over 2 plus 3, so 1/5. So the whole is at 2 comma 1/5 for this graph. So we'll put in our coordinate plane. We may need to find some test points. We'll see when we get there. So let's put in what we know. We know we have a vertical asymptote at negative 3 over here. So vertical asymptote at negative 3. We know that we have a hole in the graph at 2 comma 1/5. So we'll put that 2 comma 1/5. And we have a horizontal asymptote on top of the x-axis at y equals 0. So based on that information, we can say for sure that the graph is located here like this. So we know that part. And now we just need to determine if the graph is in this section or this section. We know for sure the right side over here looks the way we've graphed it. So now we can evaluate the function at an x value of negative 4, for example, and determine what that y value is. So do that down here. So we need f of negative 4. So we'll go back to the original function and plug it in there. So that would be negative 4 minus 2 on top, and negative 4 squared plus negative 4 minus 6 on the bottom. So keep working that out. So negative 6 on top. Negative 4 squared is 16 minus negative 4 and a minus 6 give you a negative 10. So 16 minus 10 is 6. So negative 6 divided by 6 is negative 1. So that means we have an ordered pair of negative 4, put that right here. So we know we ran a test point. We have negative 4, negative 1. So negative 4, negative 1 would be approximately right there. So that tells us this part of the graph has to be in this lower left section. So it has to approach the horizontal asymptote as x goes to negative infinity. We would need to go through that point that we identified, and then it has to approach the vertical asymptote as x goes to negative infinity. So it has to look like that based on the information that we have. All right, let's move to question 9. All right, now for question 9. So it starts out as x squared minus 6x plus 8 all over x minus 4. To save some time, I went ahead and wrote that out and fully factored it. So we start with horizontal asymptotes. That's going from our list over here. Bot needs DC. So is it bigger on bottom, bigger on top, or are the exponents the same? This one's bigger on top, so none for the horizontal, but we could have a slant asymptote, we'll see. And then vertical asymptote will come from factors in the denominator that do not cancel. We don't have any of those, so none, because the only factor in the denominator will actually cancel here, so that actually gives us a hole in the graph at 4 comma whatever the y value is. We'll find that in a moment. and the domain is going to be x cannot equal 4 because that's anything that gives us a vertical asymptote or a hole. And then we have vertical asymptote, a discontinuity at, write it this way, at x equals 4 because that's where the hole is. All right, so in this case, we're only left with x minus 2 on top. So that's all that's left, x minus 2. So we're going to substitute in an x value of 4 right there and work that out. So that gives us 4 minus 2, which is just 2. So that means that's the y coordinate. When x is 4, y is 2. Remember, when you find the value of the hole, the y value of the hole, you have to work with the function after you've canceled out the factors that gave you the hole. So that is a hole at 4, 2. And in this case, we're only left with a linear equation in the numerator, and actually the denominator canceled. So that means this is actually a line with a hole in it. So there is no slant asymptote in this case because this is just a line with a hole in it. So the y-intercept is -2, and we have a hole in the graph at 4, 2. So we'll put that in right here. And the slope is up 1 over 1. So it's going through just like this with a hole in the graph at 4, 2. So that's all that we need to graph that one. We've identified all of the asymptotes and where the holes were, domain, discontinuities, and sketched it. So that's it for this one. So that'll do it for part 2. We'll pick up question 10 in part 3.